Welcome to another Mr. Paul video. In this video, we'll be discussing 3.3, which is interpreting unit rate as slope. So we'll be connecting rates to slopes. So let's take a look at the warm-up so far. We have something like tortillas and quesadillas. You guys ever had a quesadilla before? I'm one of those people that likes to take the whole tortilla, put all my stuff on the inside, and then put another tortilla on top. So it takes me 2 tortillas to make 1 quesadilla. I'm not one of those people that folds it over. But if I wanted to make 2 quesadillas, I would need 4 tortillas. Go ahead and pause the video right now and fill out the rest of this table, and I'll see you in just one moment. I just should have known you wouldn't have paused the video. You should have paused the video and done the warm-up. Excuse me. However, let's keep moving on. If I need 2 tortillas to make 1 quesadilla, it's almost as if I had to take 2 and multiply it by 1/2. Because half of 2 is 1. I'm taking 2 tortillas and turning it into 1 quesadilla. I'm taking 4 tortillas, multiplying it by 1/2 to end up with 2 quesadillas. There's some number which I can multiply by 1/2 to get to 3. That number is 6. I need 6 tortillas to make 3 quesadillas. And some of you are like, well, Mr. Paul, why didn't you just divide by 2? Well, remember, the unit rate is some number that we're multiplying by. I just want to be clear. But there is a relationship between multiplying and dividing. We talked about that in class. 10 times 1/2 would get me 5. And 20 times 1/2 will get me to 10. I don't know why I need 10 quesadillas, but you never know. I may really like quesadillas. This small number right here that I'm circling, it's constant. It's constant. More importantly, I know this to be a rate. When the rate is in a table, it's called a proportionality constant. Proportionality constant. Also known as the letter K. When this number is the same all the way across, it's constant. It's called the proportionality constant when it comes from a table. However, it's still a rate. It's still a rate. Now, we're going to talk about a graph. When we're talking about a graph and it has a constant rate, we don't call it a proportionality constant. We call it a slope. Now, we talked a little bit about slopes the other day. They could be going up, they could be going down, they could be going flat, also known as no slope, or they can be going like this, which is undefined, right? They go to the underworld. We know slope to be the change in y over the change in x. This is how we can calculate it. So let's take a look at a graph of this situation. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Go ahead and pause the video if you need a moment to take all of this in. But I'm going to keep moving, so just pause the video if you need a second to make this. Remember, copying stuff down takes time. But I'm going to plot this information here, this table information, on the graph. Remember, a table is just a way of looking at numbers visually, okay? It's a way of putting them in a sequential order so you can see the numbers better. A graph is a way of using those numbers and being able to visually see in a picture of what's going on. But the information is still the same. If a slope is the same thing as a proportionality constant and they're both rates, I know my proportionality constant is 1/2. We knew that from earlier. So I should expect my slope to be 1/2 as well. But let's take a look. My quesadillas will be my y, and my tortillas will be my x. When x is 2, y is 1. So I'm going to go over to my graph. Remember, these are x's, these are y's. I'm going to go when x is 2, y is 1. I'm relating these two numbers in this way and putting a dot right here. When x is 4, y is 2. So when x is 4, 1, 2, 3, 4, y is 2. When x is 6, y is 3. When x is 6, 1, 2, 3, 4, 5, 6, y is 3. 1, 2, 3. When x is 10, y is 5. So when x is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, y is 5. 1, 2, 3, 4, 5. Right about there. When x is 20, y is 10. I don't have that much space, so it's going to be somewhere way over here. I have some points. I could probably draw that one a little bit better. I have some points that make up a line. More importantly, I know the slope of this line. Yes, it is going up, which means that it's positive, but what's the actual number associated with it? Well, I can check change in y over the change in x, meaning to get from one point to the next, say I go here, then here. I'm going to go up and then over, right? My up is going to represent my change in y, and then over is going to be my change in x. How much further this way and how much further this way for each step that I make. So I'm going to go make these little staircases here to kind of show you what I'm talking about. On this first staircase, to get from one point to the next, I go 1, and then I go over 2. I go up 1, I go over 2. I go up on this next one, I go up 2 and over 4. That's how much my y's are changing and how much my x's are changing. To see what we're talking about, these staircase ideas, we're going to look at this part of the table. Remember, this is the exact same information. This is just a visual, like something like a cartoon we can see. And this is more like the text. So what we're looking at with these staircases is like the change in y. So what's changing to get from 1 to 2? Well, that's plus 1. What's changing to get from 2 to 3? Well, that's plus 1. To get from 3 to 5, that's plus 2. 3 plus 2 is 5. And to get from 5 to 10, that's plus 5. Well, on the x's, to get from 2 to 4 is plus 2. To get from 4 to 6 is also plus 2. To get from 6 to 10 is plus 4. And to get from 10 to 20 is plus 10. Now, our proportionality constant, which we knew to be 1/2, is 2 times 1/2 is 1. Now we're looking at what is the change in y over the change in x. Well, let's take a look at these pictures, right? These staircases. Also, these things right here, they're also representations of the same information. Well, the change in y for this step is 1 over the change in x of the same step, which is 2. Here's another 1 over 2. Here is 2 over 4. Remember, that's my change in y over my change in x. And here's the last one, 5 over 10. 5 over 10. My fraction busting students, 1/2, 2/4, 5/10. What do they all have in common? They're all equal. These are all equal to each other. 2/4 is the same thing as 1/2. 5/10 is the same thing as 1/2, which means that my slope is 1/2. And that's no surprise because my slope is the same number as my proportionality constant. We can think of a proportionality constant is to a table as a slope is to a graph. But both a graph and a table display the same information just in different ways. They call it different things. If you know how to find a slope, you know what a proportionality constant is. If you know how to find a proportionality constant, you know how to find a slope. I hope this video helps you guys. Have a great weekend. Peace.